So now that we've learned about encoding and decoding stacks of cups, let's look at this stack. How would we encode this stack? Max, would you like to write that code? Right. As you can see from the stack, there are a lot of repeated steps required to make the stack of cups. So therefore, the code will be very repetitive. In fact, this code would require 198 arrows to write. That's a lot of arrows. There has to be a better, faster way.
Introducing functions. A function is just a set of repeating instructions. So, for example, let's take this line of code. How could you create a function that makes writing repeated arrows easy? Here, we can use a box with a 5 in it to represent repeat this arrow 5 times. So, using our new function, which looks like this, we can rewrite our code. Now, let's try building a tower that's been encoded using our new function. Ready?
Sure. Up, right 2, down, left 2. Up, right 4, down, left 4. Up, right 6, down, left 6. Up, right 8, down, left 8.
Wow, encoding using functions is a lot easier.
I'll say so. Now, remember that a function is just a pattern, or a set of repeated steps. To make the number box function, we simply noticed a pattern of repeated arrows. Can we build any more functions from this code? That is to say, can we simplify it? Do you see any more repeated patterns in the code?
Well, every line of code is the same, except with a different number. So let's look at what our individual lines do. Our first line lifts up a cup, moves 2 spaces over, and then sets it down, moves 2 spaces back. So it just places the cup in the second spot. And that line of code has a 2 in it. Our next line of code lifts up a cup, moves 4 spaces over, sets the cup down, and moves 4 spaces back. So that just places the cup in the 4th spot, and that has a 4 in it. So, our third line probably places the cup in the 6th spot, and our 4th line probably places the cup in the 8th spot.
Okay, so if every line follows the form, place a cup in this position, can we write a function for that?
Well, sure. We know that, lines of code that look like this just place a cup in that spot. So to make a function, all we have to do is pick a new symbol for it.
Alright, why don't we use this symbol right here? Now, let's test it out. Let's see how helpful our new function is by decoding this set of instructions. Well, our first symbol means place a cup at 2. Our second symbol means place a cup at 4. And our last symbol means place a cup at 3. Pretty easy, huh?
Yeah, that's really helpful. Now, let's try encoding using our new symbol. How about we encode this tower? Let's start with the bottom row. We've got, first, we place a cup at 2, then a cup at 4, then a cup at 6. For our second row, we place a cup at 3 and a cup at 5. And for our top row, we place a cup at 4. Using this new function is easy.
Let's revisit our first stack from the very beginning of the video. Looking at this stack of cups, do you see any repeated patterns? That is to say, do you see any more opportunities to use functions to make writing a code for this stack simple and quick? I know when I look at this stack of cups, I see a lot of hourglass patterns, like this one right here.
So, if we can make an hourglass by placing a cup at a position and then placing a flipped cup on top of it, then we can make an hourglass function. And we can use this new function to represent code that looks like this.
Wow, Max, that's so much faster! Using functions from our number box function, all the way up to more complicated functions such as this hourglass function, we're able to reduce a complicated code of over 100 arrows to something a lot more simple. Useful functions can make writing any process a lot easier, as long as the computer knows what the function means, of course.
This idea of breaking down a process into a bunch of repeated steps called functions is useful everywhere, but especially in programming. How might you use functions?